Okay, welcome to the Chapter 5 review for exam number 2. We're going to be going through just the sections of Chapter 5 that are appropriate for this exam, and then Chapters 7 and 10 will be in subsequent supplementary videos so that you can just pick and choose the topics that are of importance to you without having to watch, one big oversized video. So let's go through the topics of Chapter 5. If you review the topics list that I sent out earlier, you'll see a written list of all of the topics that you should be reviewing, but I just wanted to go through a couple things with you myself. So the first topic was different types of computing components. So this would be the different hardware pieces, the things that you looked into for your report on your computers. So the differences between different types of memory, primary memory, which is like your RAM, which is volatile memory, which means that it loses its data when power goes out, and then the secondary memory, which are your hard drives, your SSDs, things like that. So this is considered non-volatile memory, which means that when the power goes out, the data that you have stored there remains in storage. So the first section of the book just talks about the differences about CPUs, GPUs, DVD drives, hard disk drives, things like that. So there aren't going to be any, trick questions. It's just, covering these basic components and making sure that you know what we mean when we say these different terms. Let's see, so talking about the von Neumann architecture, which is a very, very common setup in computing, and the different components there. So the memory unit, which is responsible for holding a data, an instruction, and then the data that it's working on. The arithmetic or logical unit, called the ALU, which is responsible for performing the basic operations, the input and output units. So the examples I get, cards like punch cards, or keyboard, mouse, whatever you would use to interact with the computer itself. And then usually an output would be like displays, a screen, monitor, or a printer. And then the control unit. So let's see. So the difference between the ALU and the actual control unit. The control unit is a higher level. So it's more responsible for higher order organization and management, as opposed to the ALU, which performs specific individual operations. So if you think about going back to your homework, the things that you've seen so far, the control unit would have a couple different components in it. The instruction register, for example, which holds the copy of the next instruction to be executed. The instruction register is the one currently being executed. The program counter is the one to execute next. And then the ALU and the control unit together become the CPU. What else? So let's see. The fetch execute cycle, which looks at how an instruction is interpreted. Fetch, decode, retrieve any data, and then execute the instruction. It's pretty straightforward. Let's see. An embedded system, which is on page 143, page 143 in the book. Embedded systems are a little different from what we're used to seeing in traditional computing systems. An embedded system is more subtle in its functionality. So if you think of all of these different kinds of computing systems in your life that are something other than a smartphone, a smartwatch, a laptop, or whatever. So for example, your car has a lot of computing elements in it. Even older cars that just had control units to manage the radio or the AC, changing those physical inputs of twisting knobs or pushing buttons into actual functionality within the car itself. Coffee makers are increasingly computerized. Thermostats within the home are increasingly computerized. Anything like that where you have some sort of processing unit within the machine that would otherwise still be able to function just fine without it. So again, these coffee machines or whatever, fill in the blank. A parallel architecture then is the idea of having multiple processors that are working together on a particular problem at the same time. If they are in different locations, so for example, you can have a parallel processing problem that's being executed on a single machine if you have multiple threads, what are called threads that are running in parallel, or you can have them on different machines, such as the cloud, which are then considered to be distributed. So the idea of parallel computing is that if you have one problem that can be broken down into multiple parts, then those parts can be executed at the same time, and you can finish processing the overall task in a much more efficient, much quicker way. So there are many different kinds of scenarios in computer science research where you would perform many different tasks in parallel in order to speed up the processing of a very complex problem. Image recognition is typically done in parallel. You will have many different threads within one computer that are all running, that are all trying to recognize different parts of the image, and then they all come back together at the end and consolidate their findings and give you the overall result of what kind of dog this picture is. So it can be very helpful for large scale, very complex problems. And that's pretty much it for chapter 5. Just make sure to go through and review the material from the quiz, review your notes from the reading, and send me any questions if you have any.